in a notation. Yeah.
So does like when you have it circle as height, is that not this is that not converted from the f of x on the other side?
Yeah, it will be. So just hold on. This is your y. This is like your x. Your width is the green, and then your height is the blue.
But it's different from the f of x.
Right, because your x changes. So the x sub I is because for each rectangle you plug in a different x. So if we're going to write a Riemann sum that represents this exact area under this curve. So this is like how I get my height. Okay. And we want the exact area. So if I want a Riemann sum that represents exact area, what that means is I'm going to say the limit as n goes to infinity, I'm going to do an infinite amount of rectangles. I equals 1 or k. I'm using I just to be consistent with the other one. Okay. So this is the exact area. So this is the first part. That's what I do. Okay. The next thing I usually do, so this is like number 1. My second step is I usually figure out my width. Okay, so because I need my change in x to do the f of x part of it. Here, maybe I'll highlight that part. Okay, so I'm going to find change in x, which is b minus a over n. So if I look at my interval is from 2 to 6. So the length of my interval would be 4 or 6 minus 2. And I'm doing n rectangles, so 4 over n. So my width is represented by 4 over n. So I can go ahead and put that in my little sigma guy if I want. Okay, so then what I'm going to do is now I'm going to find like my height. So I did my width. Now I'm going to do my height. And that's that like f of x thing. Okay, so the way I set that up, okay, this is my like equation, my f of x. Okay, so what I'm going to do is I'm going to go 1/5, put a parenthesis, and square it. Okay, so like what goes in there for my x is what this fancy formula is, this like x sub I thing. Because like as you do your sigma stuff, as you like do generate all your adding, all your rectangles, your x changes because you're like moving along the curve. Like you're plugging in different x values to get all your heights. So in order to account for that, you come up with this kind of an expression. So A is where you're starting. So for x sub I, it equals A plus change in x times I. So A is 2, because that's where you're starting. Like I'm not going to plug in x values before 2. That's why I'm starting with 2. And then I'm going to keep plugging in x values after 2 until I get to 6, right? So I'm going to keep plugging in values after 2. So it's going to be 2 plus, and then I do change in x, which was the 4 over n, right? And then times I. And then that's what I'm going to plug in to the equation here. So it'd be 2 plus 4 over n I. And then, so I kind of like do all the work underneath it in a way. So this would be your answer.
Do you have to simplify that at all?
Oh, you should leave it. I is your counter. So like I is like So if I were to start doing this, like if I plugged 1 in, like if I kept going, so like my first rectangle, well, I'm going to infinity though. So like I is like if I do my first rectangle, my second rectangle, my third rectangle, because you know how like you would do this for sigma, you keep adding stuff, but we're adding an infinite amount. So the things that we're adding together is going to go on forever. And then what I'm doing is this is like the first one, the second one, the third one, the fourth one. And the way you generate it is by doing 1 for I to get this first one, like I equals 1. This would be my second one. This would be my third one, fourth one, yada yada, up until infinity.
So what does the n mean then?
The n means the number of rectangles, so I'm doing an infinite amount of rectangles. So I'm going to keep adding forever.
Yeah, so how is that different from I? How is it different from
It's not, it's just that I is like the variable that's going on forever, and is infinity itself.
Okay.
Yeah. So, all right, so just, I know, bear with me, it's kind of weird. It's weird. Okay. Usually these are at least multiple choice, which helps because you can kind of like cross ones out that don't make sense. So this one, you're going to write an integral as a limit of a Riemann sum. Okay. So the first thing I do is, because it's got an integral sign, I can go ahead and write the limit as n goes to infinity, sigma n, and maybe I'm going to go wild and use k because I've seen them both. K equals 1. You could do I equals 1 or k equals 1. Remember, they can't agree, so we just deal with it. It's so annoying. Okay. Then, I mean, you could do this. I mean, we could do the same order as the other one, but because we know it's the function is cosine, it's the x that's all weird. That's the one that's like x sub I thing. So I know it's going to be cosine of some crazy stuff. Okay. So now, because my x sub I, like what goes in for cosine has to be all fancy, like it needs to have the change in x, I'm going to find the change in x, or the dx. So change in x is b minus a all over n. So my interval is 2 pi, or pi to 2 pi. So I mean, if you can do that in your head, like 2 pi minus pi is just going to be pi over n. So that's going to be your width. So that's like the dx. Yeah.
How do you determine which one's a B and A?
Oh, the A is always a smaller one. So it always goes A to B. Is a good question.
You'll never have a negative number?
You could have a negative number, yeah.
Wait,
Because
so
you
the-
could go negative 1 to 5. So you'd be 6, you know.
Okay, but the one on the bottom is going to be your A?
Is gonna, yep, exactly. Yep. Okay, now we're gonna do this x sub I, or x sub k, oops. Gotta do k, because they can't agree on the I or the k. Okay, so then that one, remember the formula is a plus change in x times k. To be wild, I'm using k instead of I. And your a is like where you're starting, so pi plus your change in x is pi over n, and then k. So you're going to throw in pi plus, sometimes they'll do k pi just to mess with you, but that would be what you would write. That's how you translate it into sigma notation. Hence why they came up with this notation, because this is long and annoying. So they usually just shorthand it, okay? All right, next page we'll do the same thing. Maybe I'll start you off with it and then you can figure it out. Okay. So I'll start it off and then see if you can do it. So first we have an integral. So you know it's going to be this whole shebang. Do you want to go to I or K? I? Okay. I'm going back to I. Going back to our roots. Okay. So then now you're like y. I mean, this one was just like kind of basic. It was just cosine. Now you just have more x's, which makes your sigma super long. So like, you know this like light blue stuff, the teal went in for the x. You're just going to put that teal part in two spots because there's two x's. So like you're going to have essentially, what would it be? It would be 3, all this junk, squared plus 4 times all the junk minus 1. Oh, actually, I should probably put parentheses with that. And then you're going to figure out your width, and that'll be your whole thing. So it'll be super long because you're plugging in the x part in twice. So maybe I'll keep this other one up here. Try to figure out see if you can figure it out. Check with your people. Okay. How did we do?
Oh, I changed my letter halfway through.
Oh, you went to K?
I'm changing the initial to K.
K.
Oh my god, it's everywhere.
Good. Questions?
Wait, is it 3 over H or 3 over N?
N. It's always N. Yeah.
Not kind of related to that part, but like why, is it always I equals 1? Or is
Yeah.
it just
If they do I equals 0, we're gonna cut our loss. It's too confusing, or like I don't want to deal with it.
okay.
I've never seen it 0, maybe once. So I don't. It's not gonna deal with it. No. It's whether they deal with the left or right. We usually deal with right. So don't worry about it. All right, so this one's a little harder. Do you know what makes it hard? More than one way. Okay, so you ready? You're gonna be ready. Okay, see this whole shebang? Guess what that turns into? Boop. Okay, we're gonna do 3 of them. 3 different ways. Okay. Okay, so all of them are gonna have an integral sign. Okay. Now, the key is what are you gonna let be your function? And you have to be paying attention to what your width is gonna be. Okay. So, this is what I'm thinking for our first one. Okay. This is what I'm going to have be my function. This is gonna be my x sub I, and this is gonna be my width. You see how I kind of broke it up? How we're going backwards basically, right? So, actually maybe I'll put this here. So like here, my x sub I is 2 plus, now what I like to do is kind of separate the width from the, like, you know how it's like the i's on the numerator or whatever? I like to kind of keep the width kind of in its own little, like, thing here to make sure that it matches what's over here, okay? So that's what I'm going to let my x sub I be. So, because I know it's going to be an integral, remember this is like your a. So we're going to go from 2, and then my width, remember this thing is that b minus a, right? The change between them is 5. So if I start at 2 and the change between them is 5, this is going to go up to 7. Okay. Okay, so then for my function, it's going to be natural log. My x is just this, just x, that whole chunk was x. And then dx is my width. And there you go. Okay, I'm actually going to put some more room here. Now I'm going to do it a different way. Okay. So I'm going to actually rewrite this sigma stuff. Oh, whoops. I'm used to the other stuff I've been doing. Okay, so here, now this is what I'm going to do. I'm going to change what my f is. Okay. What I'm going to do is I'm going to change it to natural log of 2 plus. And I'm going to let this be my x sub I. What? This is where it gets intense. Okay. So, this is going to be a little wild. Okay. So the 2 I made part of my x, right? So if I let my x sub I equal just 5, what would that be? 5 over n times I. That means I have 0 being added to it, right? I don't have anything being added to it. So I know it's going to be an integral. And my function's going to be natural log of 2 plus, this is going to be my x, okay? But what I'm choosing is my integral is not going to start at 2. What I'm doing is my integral is going to start at 0. So it's messing around with the numbers. So I'm going to go from 0, and then again, my width is 5, so this is going to go up to 5.
Wait, I don't.
So I'm changing what my x sub I is. So my first x sub I was this huge chunk.
You just let them get
Yeah.
used to be it.
Yep.
So then,
So now the other one, I'm choosing the idea of like, oh, 2's part of the function, like part of the equation. Okay. Okay, you ready for the worst one? I'm going to do a third one. This is going to be some math.
Does that need the dx one?
Oh, whoops. Yes, you do. I almost died. Thank you. Okay, now this one. Limit, and you're going to get really annoyed writing these. Okay, so we're going to have an integral. Shocker. Okay. Now I'm really gonna do some finagling here. Okay? So, you know how that 5 was over here? Okay? I'm gonna put the 5 way at the beginning. I'm gonna put that 5, this is all multiplication. So this is what I'm gonna do. I'm gonna put a 5 here. Just hold on, just go with it for a sec. Okay, and then I'm gonna do natural log, and then I'm gonna do 2 plus, and I'm gonna take the 5 out from the other one. Just hold on, don't start crying yet. And my width, or my x sub I, is gonna be I over n. And my width is gonna be 1 over n. So I'll just let it sink for a second. Let you write it down. So do you see this 5 over here? I changed that to like 5 times 1 over n. Think of it as like, I changed 5 over n to 5 times 1 over n. Right? Is everyone okay with that? So I threw that 5 over here out way over in front. Okay? Now because my widths have to match, I brought the 5 out of this guy too. So I brought the 5 down over here. So what I'm forcing to happen is I want my x sub I to be 0 plus I over n. So for my integral, I want it to go from 0 to 1, because my width is 1. And my function is going to be 5 natural log of 2 plus 5. And my x is right here. Told you it's hard. Yeah.
Why didn't you factor out the 5 from the I over n?
I technically did. I like took it out. Cause it was like, it's the same kind of deal, like 5I over n is the same thing as 5 times I over n.
So would you just apply the 5 at the front to the 1 over n? Like if you were to factor it?
Well, it's in the natural log, so I can't take it out. But
Why wouldn't we just do the easy way?
because multiple choice is gonna say which one's correct.
And it's not gonna be.
1 and 2. 1, 2, and 3. Just 3. So, all right, I'm gonna do one more. Have you guys? How much time? Oh shoot. Okay, let's do C, and then see how many ways you can write it.
Can we not do it by ourselves yet?
You're not
I would
ready?
like to just have notes to
One
help
more?
do my homework.
Okay, that's fine. Let's do this integral. Okay. Figure out where your function is. So the easiest one is when this is your x sub I, right?
Why not the whole thing though?
Because you need a function still. Like you still need like an equation. Because like now this is your height, 8 minus 4, and then x. So your equation is going to be 8 minus 4 x. And this is your dx. Okay. So the biggest thing is figuring out where you're going to start and then what your bounds are. So if that's what your x sub I is, it means that you're going to be starting at 5 and you have a width This is your width, remember, of 4. So if you're going from 5, then you're going to go up to 9. Because you need a width of 4. Okay. If you rearrange some of this stuff, like say I do the same thing we did on the last one. Okay. So what I'm going to do is I'm going to rearrange the numbers in here. So I have, excuse me, goes to infinity, I equals 1, goes to n. And what I'm going to do is I'm going to take that 4, I'm going to change what my function's going to be. I'm going to take that 4 and throw it out front. Here, I'll do bracket. And then I have 8 minus 4 parenthesis. And maybe I'll change it to 5 plus 4 I over n. Because what I'm looking for is that I over n, it has to be the same number as that width, 1 over n. So I put the 4 way at the beginning, and then I drop the 4 out of the in part, the part that's changing, and that's where my x is going to go. So I know it's going to be an integral. My x sub I is 0 plus I over n. So because of that, my integral is going to go from 0 to 1. Because I'm starting at 0, the dimension of it is 1. And I'm going to put an x in place of the I over n. So this equation is kind of goofball, but... And then dx. Actually, this is where the x goes.
Why? How do you know what to add for the x? I. How do you know to start 0 plus?
Because there's nothing else around it. Whereas the other one had this part being starting at 5. I don't know, there's stuff getting added to it. The width has to match.
I don't know, I'm
I
understanding,
know.
I'm understanding the first one, the second one I understand a little.
Okay,
This is not.
I don't know, I can come back.
What?
I'll come back, because I want to make sure we get to these ones. Okay, these guys. Okay, this is like they have it written out. It's not in sigma notation, but they're adding. Okay, so what you want to pay attention to is what's changing every time. So the stuff that's changing is this guy, right? See how it's changing every time? It's always plus 3. It's always the 1 over. The only thing that's changing is that part. So that's how you know it's going to be 1 over x plus 3. That'll be your function. Because that's the part that's changing every time. Plus your integral has to be dx. And we're taking a limit to infinity. So I know it's going to be an integral. Okay? So if that's what's changing every time, okay, they have it written out like they're actually, there's no i's in this one because they're doing the first one, the second one, the third one, dot, 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 to infinity. They like wrote it all out. This guy is your width, right? They have it at the front, which is like, why are they doing that? But whatever, we're just going with it, okay? So essentially what you have to think about is like this is hence like your x sub I, right? And notice there's nothing being added to it, there's nothing in front of it. So that's how we can know that this integral is going to start at 0. Okay, because there's nothing being added to the 2 over n, the 4 over n, the 6 over n. It's only the 2, 4, 6 that's changing. And what's changing is, you see how this dimension is 2, that's why it's going up by even numbers. So because of that 2, I know that I'm going to integrate from 0 to 2. My voice is slowly going away, getting nervous. That's how you get that one. Okay, maybe. This one, they're just doing normal Riemann sums. They're saying, like, what's an approximation for what definite integral? So it's the same kind of idea. You know, like, figure out what is changing each time. This is the thing changing, right? The stuff in front of there. So my function is going to be cosine. My x is the thing that's changing. We're always doing with, so this is always going to be dx. And we're adding up all these widths in order to get an integral. Okay? So, like, if you were to distribute it out, like, think about if you were to distribute it out, you know, like it would be 1/10 times cosine 1/10, right? And then it would be plus 1/10 cosine of 2/10, dot, 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 1/10 times cosine of 10/10, right? So think about what your dimensions are going to be. We're not adding to the 1/10, right? It's just staying the same. So I know it's going to start at 0, but what number is it going to go up to? I did 1/10, 2/10, 3/10, all the way up to 10/10 to 1. Yeah, because 10 divided by 10 is 1, right? So essentially we're doing cosine from 0 to 1, and we're doing 10 rectangles. This 1 over 10, we're doing 10 rectangles from 0 to 1. So your n is like your 10, right? That's what usually goes there.
So how did you get one?
Because the first one is 1/10, so but then you're going up to 10 over 10.
Oh, okay,
So it's like you're going from
How do
a
you
little
know,
past 0 and then to 10 over 10.
how do you know it doesn't start at 1/10?
Because we're doing a right Riemann. Because you're almost always doing a right Riemann for these.
It doesn't say that though.
I know, but because you're going up to 10/10, it means you're using the last value of the rectangle at 1. So like when you're getting these values, like if you drew a picture of it, right? You're plugging in 1/10, 2/10, 3/10, 4/10, and then 10/10. You know what I mean? So you're using the last one.